Assalamu alaikum dear students. How are you? Hope you are all fine. Today we have another part of the chapter number 1 of AS Physics, and this is the topic here, components of a vector, and then we will do the resolution and composition of a vector as well. Actually, there are few definitions which we must understand first, and then of course we can move ahead. Here the first definition is the coplanar vectors. So basically we have to understand what is the meaning of coplanar. Coplanar means that two vectors lying on the same plane, and coplanar means of the same plane. So simply how you are defining the coplanar vectors? Coplanar vectors are vectors that lie in the same plane. Now what is the meaning of same plane? Here you can see these two diagrams like this one. Suppose you know already that if we have a sort of cube or a rectangle or a sort of room, you can say, so that room will have a sort of a volume, and then we can say that we have a certain axis, like over here we have x-axis. This is our x-axis. Here we have the y-axis, and we are considering this line as a z-axis. So we can very simply understand this point, that if this is our x-axis, that this line, the line just in front of it will also be your x-axis. Over here you have x-axis. Similarly, if we are considering this axis as z, so this axis which is parallel to this one will also be z, and similarly here we have z, here we have z. So if you are considering a line or axis, then you may have x-axis, y-axis and z-axis, but when you will have the intersection of these two, yani x-axis suppose and z-axis, the combination of these two axes is giving you a plane. So simply you can say that here we have a plane which is suppose the floor of this room. So where is the floor of the room? Here you have, so xz is basically the plane. So simply you can say that this plane is xz plane, xz plane. Similarly, if you are considering another situation and you are considering suppose this one, this side of your rectangle block, suppose a room, then you know that here you have z-axis and here you have y-axis. So simply you can say that this plane is nothing but of yz plane, or this is nothing but yz plane. And similarly here you have the roof also as xz plane. This side again is yz plane, and the front side of your room, which you can say is given by yellow color, is nothing but of xy plane, xy plane, because this is the combination of your x and y. So the combination of xy is giving you this front side or even the back side, and this will be the xy plane. Similarly, we can take this line, suppose here we have x-axis and here we have y-axis. So we can consider this as x-axis, this is y-axis. So this will be our, say, z-axis. So if you have a vector, suppose p vector, which is lying on this plane, which is the xy plane, then you may have another vector which is suppose lying somewhere here, say r, or another vector which is somewhere here, say q. So all these are coplanar vectors because they are all lying on the same plane, xy plane. But on the other hand, if you have this situation that this is your x, so this is your x, and this is your also x, so this is your xz plane. So simply you can say that if we have vectors somewhere here, say vector a, here we have vector B, suppose here we have another vector which is C. So all these vectors are coplanar vectors because they are present or lying on the same plane, in this case xz plane. So this is the situation as far as the coplanar vectors are concerned. So this is very important to understand, and of course in your syllabus you have this term, so you must know the definition and you must have the understanding of this definition as well. And the another point, another definition is components of a vector. Now suppose here we are considering one thing, that suppose here we have a block, and on this block we have a force like this force F1, we have another force which is say somewhere here which is F2, there is another force which is suppose somewhere here which is F3. So all these forces are basically giving you one you can say effect or final effect. So the final effect will be the resultant vector. The combined effect of two or more vectors is called resultant vector. So the final effect of all these three, F1, F2 and F3, we can write in this way, that vector F1 and F2 and F3, these three vectors are components of a vector, and the resultant of these three is nothing but vector F. When we will go for the addition of vector, then we will do this thing again in detail, but for the time being I am just telling you that what is the meaning of components of a vector and what is the meaning of resultant of a vector. So what you can say, that we suppose we are starting from a point A, we move to another point, suppose B. So we can say that this is one distance covered or displacement in a particular direction. Then we have another displacement, say from B to C in another direction. Then we are coming somewhere here. So this is our suppose point D. So when we are considering these vectors A, B, B, C and your AB to BC, BC to CD, so all these vectors ultimately giving you the final effect, that is nothing but vector AD. Yani basically what is your displacement, final displacement is nothing but this displacement which is AD. So what you will say, that vector AB plus vector BC and plus vector CD are giving us another vector which is AD. So all these vectors AB, BC and CD are termed as components of a vector of AD. So this is very important. So this is AD, which is the resultant in this case, as we have just discussed that here we have F as the resultant vector. Now when you will go for the component of a vector, you can say that we have a vector AD and we can divide or resolve this vector AD into AB, BC and CD, and you can say and see that in between these vectors, like in between B and C, we have this you can say angle, between C and D we have this angle and so on, but all these are components of the vector AD. On the other hand, if we have a situation that we have suppose two vectors in this way, that they are perpendicular to each other and they are of course giving us a resultant vector, suppose here we have P and here we have Q. The resultant of these two is nothing but suppose R, then we can say that this R is the resultant vector and P and Q are the components. But what is the difference between these components and the components over here? So like suppose if we are considering these vectors as say like suppose your E, F, G and here you have H. So you can say that E, F and G are components of vector H, and vector H is nothing but the resultant vector. But in this diagram, what you have P and Q. Vector P and Q are giving you the resultant vector, which is R. So what is the difference between these two diagrams? Here you have one diagram, diagram 1 you can mark. This is diagram 1 and this is the situation, or diagram 2. So what is the difference between these components? So simply you can say that in diagram 1, our vectors E, F and G are making any angle but not of 90 degree. So they are just termed as the components of a vector. But particularly when the angle between the given vectors like P and Q in this case is of 90 degree, here you have this angle which is 90 degree. So you will say that P and Q are the rectangular components of the resultant vector R. So this is the situation over here, that R is your resultant vector. Here you have H as the resultant vector, but what is the difference in components? So specifically we can say that when components are making an angle of 90 degree between them, they are termed as the rectangular components. Otherwise, of course, you may have components like in this case you have component of vector H as E, F and G. So this is something which is very important to understand, that components may be any components, or we can divide our resultant vector or into a number of components. But if we are dividing, or if we are you can say drawing these vectors in such a way that they are making an angle of 90 degree, then they are termed as the rectangular component of the vector. Now quickly we just want to know that how we can dissolve a vector into its rectangular component. So I have just drawn a very simple diagram, and we can redraw this just to give you the idea and the little mathematics about this situation. Here suppose you have one vector and here you have another vector. So simply what you can say that the say vector OA here and AB is in another direction, but what we have just observed that the angle between them is of 90 degree. So if these two components are given, then what will be the situation? The rectangular components are given. But if on the other hand, which is the actual case for us for the time being, we have a vector here which is vector OB. So what actually we are doing, or what we can do here, we can draw the line of x-axis and y-axis. Of course your horizontal line is x-axis, and your lines, here you have x-axis, here you have y-axis. So here you can say that the vector OA of vector V, suppose, is lying along the x-axis. Your vector V is making angle of theta, and the part of this vector V, or one part or component of this vector V, is lying along x-axis. So simply you can say that vector OA is nothing but the x component of vector. So we can say that this is Vx. Similarly, if you will go for AB, then AB, vector AB is basically the vector which is lying, or the part of the or component of vector V which is lying along y-axis. So simply you can say that this vector is the y component of your resultant vector or vector V. Now the thing is that if you have the triangle, we can write here in triangle OAB we have what we have, and actually what we are doing, we are resolving our vector. So which vector we had? We had vector v, and what we are doing, we are resolving, yani we are dividing this vector into its components. Which component? Your rectangular components. What are rectangular components? Components of a vector making an angle of 90 degree between them. So remember this thing, that the angle of the vector will be or may be any angle, but the component which are rectangular components of your vector v must have an angle of 90 degree. And in triangle OAB, simply you know that if you are considering here the trigonometry, then cos theta is base over hypotenuse. So what is the base in this case? So simply you can say that this is nothing but OA, vector OA. So what is vector OA? So if we are interested to know the magnitude of vector OA, which is nothing but Vx, and what is hypotenuse? So this is vector v, and we are using the magnitude of vector v. So simply what we are doing or what we are getting, by multiplying v by cos of theta, we are getting the x component of a vector. So one of the component, which is, you can say, the adjacent side, I am just using this term adjacent side, and which is base in this case, is given by v cos theta, or we can find out the x component by using this simple formula, vx is equal to v cos theta. So these are actually very important terms, and you have to remember these terms, because in the coming chapters like forces and other momentum and torques, which are the vector quantities, we may use or we have to use these you can say relations and these equations. So Vx you can find, or x component of the vector v you can find by multiplying the cos of given theta by the magnitude of the given vector. So Vx is equal to v cos theta. Similarly, here I can write in this way that if you are considering sine theta, then what is the situation? Sine theta is nothing but given as perpendicular divided by hypotenuse. So the ratio of perpendicular and hypotenuse is giving you the sine of theta. So what is the situation in this case? So simply you can say that perpendicular is nothing but r Vy. So if we are using, or if we want to find out the value of or magnitude of Vy, any y component of the given vector v, we can use v sine theta, and as we have just done Vx, we have written v cos theta, or we have this formula for Vx. On the other hand, now we have Vy is equal to v sine theta, yani when you will multiply the value of sine of theta by the given value of the vector, you will get the y component of your given vector. So these are very important equations, and you have to remember these equations if you want to find out the value of Vx and Vy. Now if you have the other situation, composition of a vector from its rectangular component. Now what is the situation? I can simply use that if you have the values of Vy and your Vx, and in this case suppose your Vx and Vy values are given and you want to find out V, then you will say that you have the situation of composition of a vector from its rectangular component. Now in this case what we can do, simply you can write that here we have another situation, and the situation is, now we have triangle OAB, and by using the Pythagoras theorem, you know that the hypotenuse square is equal to base square plus perpendicular square. So in this triangle, what we have, hypotenuse is nothing but your V, so V square, base is nothing but Vx, so this is Vx square, and perpendicular is nothing but Vy, so this is Vy square. So simply we can say that we have V equal to square root of Vx square plus Vy square. So remember this thing, that here you have a situation of the magnitude of the resultant vector, yani this equation 1, the above equation 1 will give the magnitude of the resultant vector, magnitude of the resultant vector. If you will go back to my previous lectures, you will see that we can use this V for the magnitude, or we can use the mod of vector or modulus of vector V. This is also giving you the magnitude of vector V, which is the resultant vector. So if the values of Vx and Vy are given, very simply we can find out the magnitude. So here we can write that this is for magnitude of the resultant vector. But remember this thing, that whenever you will use the term vector, you have to think that the not only magnitude, but we have to have the direction, or we should know the direction of the vector as well. So by using the equation 1, if your values of Vx and Vy are given, you can find the magnitude of your resultant vector. But on the other hand, you also need the direction. So what you will do for direction? Direction of the resultant vector. So simply you can say that if we want to find out the direction of the resultant vector, and of course we need to use the given quantities, like, or given vectors Vx and Vy. So we know that the base and perpendicular is given. So what we can do, what we can write, simply we can say that now for the direction we have another ratio, trigonometric ratio, tangent theta, which is nothing but perpendicular over base. So this time you have value of a Vy, you have value of Vx, and by using this simple formula of tangent theta is equal to Vy over Vx, you can find the angle. And how you will find? You will take the inverse of tangent, which is basically Vy over Vx. So this will be the equation 2, which will give you the direction of your resultant vector. So you can write the equation 2 gives the direction of the resultant vector. So this is what we have. You can take examples, like suppose if we can go to the next page, and example if we are considering here, then example is simple. Suppose we have, first of all we can say that we have a force of say 10 Newton making an angle of theta of 30 degree with x-axis. What are fx and fy? So simply what you will do, fx is equal to f cos theta, and you know that the value of f is 10 and cos 30 is the value which you can find very easily, and this will give you the idea that what will be the value of your fx. You know that cos 30 is nothing but 0.866. So ultimately you can say that fx is nothing but your 8.66 Newton. So this is what you have. On the other hand, if you want to find fy, then f sine theta you have, and f is 10 and sine of 30, yani you have to use the same angle for the force which is given. So you will use the same angle in both the cases. Of course the values are also same, but you know that in one case you have cos theta, in another case you have sine theta. So the value of sine 30 is 0.5. So simply you can say that the value of fy is nothing but the value which you have, like suppose here you have 5 Newton. When you will multiply 10 by 0.5, you will get the value of 5. And similarly, you can use the same values even here. If you have suppose this situation, that values of your like fx is given, your value of fx is given as suppose 8.66 Newton. I'm just taking the same example just to reverse the situation. And here you have one situation where the force is given and a vector is given along with the angle, and you want to find out the x component and y component of the vector. So these will be the simple steps. But on the other hand, if you suppose have this situation that force is given as 8.6 and fx is given as 8.6 and fy is given as your 5 Newton, and you want to find out f, then what you will do? So simply you can say that for magnitude we will use the formula f is equal to square root of fx square plus fy square. So simply what you have to do, take this value 8.66 whole square and 5 whole square, and when you will calculate this whole thing you will get 10 Newton. I'm not doing the calculation, but just to show you that if you have these values given, then what will be the result or resultant value, and if the resultant is given, you can say the vector is given or the force is given with a particular angle, then how you can find out the x and y components. So this is something. Here you have 10 Newton, but as I said that you need direction as well. So when you will go for the direction, what you will do? Simply you know that tangent theta is equal to fy divided by fx in this case. So simply you can say that tangent theta is nothing but fy means what is the component y? 5 Newton. And what is the component over here? So this is 8.66. When you will calculate the angle, again you should get the value of 30 degree. So I have just taken these values to simplify the example. So if you have this situation that the force and the angle given, then you can find out the x and y components. But on the other hand, if they have given you, this is the second situation, you can say they have given you the force and not the force only in terms of your you can say resultant force, but the component of the force is given, and this is fx and fy. So what will be the resultant force? So 10 Newton will be the resultant force, and as I said that I have taken these two values from here because I just want to simplify the example. On the other hand, if you have tangent theta, then tangent theta is nothing but Fy over Fx. So values of Fy and Fx are 5 and 8.66 respectively. When you will use this simple calculation, you will get theta, which is 30 degrees. So you can say that in this case, when you will draw the resultant vector will be supposed somewhere here, making an angle of 30 degree, and the value of this force, magnitude of the force, is given by 10 Newton. So this is your resultant force in this case. Of course, the angle is in between the vector and your x-axis. Same is the case here. If you have the force given, which is of 10 Newton, and of course I am not drawing a diagram to scale, but just to show you that what is going on. So F Newton here, so simply the two components we have as Fx and Fy, and their values we have already calculated. So the Fx is given as 8.66 Newton and Fy as 5 Newton. So this will be your diagram. So when you are going to resolve your vector into two components, these two formula you will use, and even you can write it here above the above two equations, like if equation A and B we can mark, equation A and B will be used to find out the x and y components of a given vector. So this will be the resolution of the vector, and on the other hand, when you have these values of x component and y component, then you want to find out the resultant vector, and this will be the, you can say, simple two-step procedure. You will find out the magnitude by using the Pythagoras theorem, and this is the equation you have. On the other hand, of course, direction is also required. So the direction will be calculated by using the tangent theta is equal to perpendicular over base, or particularly if you want to write, you can write in this way that theta is equal to tangent inverse Vy over Vx. Please remember one thing, that here I am not using V for volume or velocity or whatever. This is just to symbolize the vector. So this is what we have. I hope you have understood this discussion, and inshallah in the next lecture we will complete this discussion. So this is the lecture for today, and if you are new on my channel, subscribe my channel, like my channel, share my channel, so the other students can get the benefit of this discussion and these you can say lectures as well. So inshallah, see you in the next lecture. Till then, Allah Hafiz, take care.